Hi, I just want to make this quick video talking about how to multiply together large numbers in a fashion which falls in line with what we're taught in school. Now, if you search over YouTube or Google how to multiply large numbers, there's often tricks involved. And me personally, as a physicist and a mathematician, I find it really unsettling that people are more concerned about tricks and tips on how to, multiply large numbers or do long division and so on and so forth, rather than actually appreciating the underlying mathematical foundations. The main mathematical foundation is our times tables. There's a reason why we were taught this and we were told to learn this so so heavily during school. So times tables from 1 to 1 to 12. These numbers here, they are pretty much ubiquitous, and by the time you get to large numbers, all you're doing is multiplying them by powers of 10. So if you have a really funky multiplication that you need to do 10 times, literally 10 times out of 10, it's usually one of these numbers and another one of these numbers in various powers of 10. And I'll show you what I mean by that right now. So let's take an example. 14 times 16. Now, you would probably just want to put that in your calculator and just do it. Now, this isn't anything practical. If you're doing quick maths, at the store, or you just want to get an answer quick, okay, fair enough. You're gonna use a calculator, but in order to aid your understanding of maths and improve your mental maths, then yeah, this is a good idea to learn how to do. So 14 times 16. What I usually like to do is that I like to split the 14 into two numbers, and I like to split the 16 into two numbers. So 14 times 16 is 10 plus 4 in brackets multiplied by 10 plus 6 also in brackets. Now this looks familiar. This looks like algebra, because if you recall what we learn in algebra, we have a plus b multiplied by a plus b, and we're simply taught how to multiply out brackets, and that's going to give us a squared plus 2ab plus b squared. And b and a can be different letters or numbers, whatever you want. It's the same concept here. We're going to multiply out these brackets. Basically, we are spreading the difficulty. So we're narrowing down the difficulty, and we are, attacking it in a piecemeal type fashion. So let's multiply out these brackets. So it's going to be 10 times 10 plus 10 10 times 16. So 10 times 10 plus 10 times, not 6, 16, 6. And then we have 4 times 10 plus 4 times 6. And that should be a multiplication sign right there. Okay? And all we have to do is just do our times tables. So, we should know what these equal, but if you didn't know, you can just read them off here. 10 times 10 is 100. 10 times 6 is 60. 4 times 10 is 40, and 4 times 6 is 24. So that leaves us with 100 plus 60 plus 40 plus 24. And when we add those together, we get 224. Okay. Okay, you're probably wondering, okay, that's really cool. That, I could probably have done this in my head. I mean, I could, if I knew what 16 times 10 was, which is 160, all I'd need to do was just 4 more of that. So this is the same thing as 10 plus 4 times 16. 16 times 10 is 160. 16 times 4 should be, I don't know, 50 something. No, 4 times 10 and then 4 times 6. So that's going to be 64. And add them all together and you get 224. So you're probably wondering, okay, that's not too hard. Okay, let's do something a bit harder then. How about I just, from the top of my head, 365. I came up with that number because there's 365 days in a year or something like that. I always mess up that number. How many days are there in a year? Anyway, 365 times 28. Okay, this is a bit harder than simply splitting that up, but the same method applies. What you really want to do is that you want to get something in a as 10 somewhere. So something as a multiple of 10. We have two multiples of 10 here. We have 360, that's a multiple of 10, then plus 5. And we are multiplying that all by 20, which is a multiple of 10, plus 8. So I split the 28 into 20 and 8. And then we're going to do the same thing, multiplying out the brackets. So this is going to be 360 times 20 plus 360 times 8 plus 5 times 20 plus 5 times 8. We're going to add everything together. The hardest one to do here, just off the top of your head, is this one. I know that 36 times 2 is 72. And all I have to do is add 3 zeros. All I have to do is add 3 zeros. So if I just do this in red, well, I know that 360 times 2 is going to be 720. And all I have to do is add another 0. So that's going to be equal to 7,200. I don't know what this is yet. That's going to be equal to 100. And this is going to be equal to 40. Okay. So we are going to break this one apart. And you'll find that it's still the same type of situation where we just change that into another power of 10. So that's going to be 300 plus 60 all multiplied by 8. So at the end I have 300 times 8 brackets plus 60 times 8 in brackets. Okay. Now I know that 8 times 3 is 24. Then I just need to add 2 zeros. So that's going to be 2,400. And I know that 8 times 6 is 48. I just need to add another 0 there as well. So that's 480. So that altogether is going to give me 2,880. So 365 times 28 is equal to 7,200 plus 2,800 plus 100 plus 40. Now we have some big numbers to add up together. Okay. This is going to be 9,000, 10,000, 10,080. So this above equals 10,080, because what I did here was that I just dropped that 80 to the side and just had 2,800 plus 7,200. Those both together equal 10,000, and I just added the other 80, then plus 140. So altogether I have 10,220 as my answer.